Attendees are in listen-only mode.
Hi everyone, this is Shannon Williams from Rancher, and thanks for joining us for today's online meetup, plug and play container storage and networking in Rancher environments. We are excited to have an enormous crowd. I was just tweeting out that I was kind of shocked when I went to start the webinar and I realized there were 830 people registered for today's meetup. So it looks like it's a popular topic. Hopefully, we'll be able to give you guys everything you're looking for and to hear. We're going to be showing some stuff that is that's brand new. So as always, be prepared for some fun. I'm Shannon. I'm one of the founders here at Rancher, and I work with our users around the world. You can follow me on Twitter at smw355. Someone asked me the other day what that is. It's actually just the random name they gave me when I went to college, and since it's random, no one ever takes it, so I can always get it on everything. So that's what it is if someone's ever curious. Darren's much cooler. He actually has a real name that makes some sense. Darren's my co-founder and our chief architect here at Rancher. Darren, you want to say hi?
Hi, this is Darren.
All right, so this is the last few meetups. We've had a lot of other people presenting and people coming through, but we're kind of throwback meetup today because it's really just going to be Darren and I talking. As always, it's a meetup. It belongs to everyone that's here. This is a place to share ideas and talk openly. When you ask questions, we try to respond and answer them out to the whole group. We love other people to join us and present and share their stories. So if you'd like to, send us a question or suggest a topic. If you'd like to present at an upcoming meetup, we'd love it. We'd love to hear about, logging, monitoring, Kubernetes, Mesos, Docker, microservices, CI/CD. There's really no topic we aren't interested in on this meetup. So it is typically a group of, relatively hardcore Rancher users. So we have lots of people who are using Rancher, evaluating Rancher, trying out Rancher, trying to learn about the space. We do try to kind of have a set of rules. So they're pretty light rules. We don't really do a lot of rules anyways. The rules are we always run late, so we don't bother too much with timing. We try to get this thing done in an hour, but that almost never happens, at least not when Darren and I are here. I guess last month's went fast because someone else was presenting. We were traveling. So unfortunately, we're back, so the time may be a little bit long again. That said, we recorded the whole thing. It's being recorded now. We post the recording up online, so don't worry if you leave. You can always come back and watch the rest later. There's plenty of, we make sure all of our failed demos are online and recorded for everyone's enjoyment and amusement later. As always,
Shannon, are you showing any slides right now?
Yeah, I am. Are they not showing?
I don't see anything.
Can you see it now?
Yep, I can see it. There you
okay, great. Sorry about that. I was just going through a couple slides. That's the second time I've done that. See, we always record them to show off all the things we do wrong. Okay, so sorry I wasn't showing slides earlier, but here you go. We'll be going through today and, just ask your questions in the sidebar here within, within GoToWebinar. It gives us a chance to try and answer them as they come in. We'll share them out. The whole thing is meant to get as quickly as possible to demos. So we try not to spend a lot of time on slides. Today we're going to be talking about some concepts. So we'll talk a little bit. There'll be a few more slides than usual, but again, we're going to move pretty quickly through them, and then we'll be demoing a lot of storage and a lot of other cool infrastructure stuff inside of Rancher. So the reality is almost always we're showing stuff that isn't quite yet fully baked or released. Today we're playing with some features that will be coming out in 1.2 Rancher, which is another 6 weeks away or so. No, I guess it's only 4 weeks away. It's sort of end of October timeframe. So things break. Be patient. If we try to tap dance around them and have backups and have sort of cakes baked in the oven, but some of these things, the whole point is showing how to set them up. So if something's not working quite right or we're losing internet, bear with us. We'll do our best. Okay. So one thing, we do try to make this a bit of a community, and even though we can't all be in the same place, it's awesome when you make yourself known to everyone else. So we use a hashtag that's just Rancher Meetup to share our thoughts, ask questions, suggest topics. It's a great way to talk to other people who are in the community and just you want to ask questions about. So if you're new, post your picture. If you haven't already, you know, or if you're doing something different, share with us what you're doing. We have people from every continent joining, people eating their lunch, you know, late at night, getting up. So whatever works for you. I saw people already joining in Tokyo, where it is incredibly early. So thank you to our friends over there who are joining very early in Japan. Today's agenda, we're going to be going through really just talking about this concept of pluggable infrastructure services. So I'll walk just really, you know, my typical 2-minute overview of what is Rancher and who are we. But mostly we're going to be talking today about pluggable infrastructure services. Darren's going to demo a lot of things. We'll be going back and forth, answering your questions, asking your questions, and showing you how to start doing this stuff. For anyone who doesn't know, Rancher is an open source software company. We're based in California and Arizona, but we have teams all over the world now. I think we're up to like 45 people, including China, the UK, Germany, Spain, you know, Canada, Japan, and you know, hopefully more places soon. So we have 2 main projects. One is Rancher, which is what we're going to be talking about mostly today. Rancher is an open source management platform for containers, and Rancher OS, which is a tiny, now I think 40 or 50 megabyte Linux distro that runs Docker as PID 1 and basically minimizes the operating system footprint. They're both open source. We provide, as a company, we pay our bills by providing support services and you know, integration and consulting around these technologies. So if you ever need help, let us know. But you know, it's all open source. It's all free. You can use everything we talk about today to your heart's content. Fork it, change it, do whatever you like with it. So just really quickly on Rancher, you know, to help people understand, if you're new to the Rancher community, Rancher is a full container management platform. And what that means is really everything from the compute layer up, we allow you to provision and use to run your containerized workload. So Rancher creates, you deploy Rancher as a platform. It connects to whatever infrastructure services you're using, from bare metal and VMware in the data center to really any clouds you can imagine. And users basically create and provision environments. An environment is a cluster of hosts that get networking and storage services allocated to them that lay down an orchestration tool, so you can choose between, you know, popular open source like tools like Kubernetes or Mesos. We have our own cattle solution. You can use Swarm. So you pick the orchestration that you want to run on top of the cluster. And Rancher sort of provides around that all of the user management, the operational management of the infrastructure, the visibility, the monitoring, the APIs, CLIs, you know, everything you need to plug it into your process and run your applications on it. So it's about a 2-year-old project. It's incredibly popular. I think we're over 1.5 million pulls from Docker Hub now for the Rancher management server, and I think this month we're going to pass about 10 million pulls of agents out there. So it's growing really fast, and we love hearing people that are using it. There's tons of information on our website if you just want to learn more about it. So that's a little bit about Rancher, and you know, we're currently on release 1.1.4, I believe, is the latest stable version, and 1.2 pre-3 is the current next sort of upstream version. So we're working towards a 1.2 release, which is what we're going to be talking about today. And you know, when we were getting ready for this session, you know, we've had a number of requests during the meetups to talk more about infrastructure and talk more about storage management and networking, and, you know, how do I persist data? What are the best approaches? So we're gonna spend today talking about sort of the direction we see infrastructure services going around containers, and how you know, between some of the standardization efforts going on in CNCF and OCI, and you know, what's happening inside of some of the orchestration tools like Kubernetes, Mesos, and Swarm, we're getting closer and closer to a world where basically we can run any type of storage and any type of networking overlay on our computing clusters. And in Rancher, we're introducing really a lot of cool concepts around how you manage that and how you plug those different services in, and have this sort of universal plug-in type of framework that, you know, you can say, hey, I want to use NFS storage and deploy a Kubernetes cluster with a Calico overlay network, right? That should be, you know, a basic design decision, one click, and, you know, stand it up and deploy it and implement it. So that's the kind of stuff we're working on, and we'll demo as much as we can now and show you how it's looking. But it's all kind of coming from, I think the big idea that has pushed us since we started Rancher. We're moving, faster and faster towards a world where the different cloud platforms themselves are really, they're becoming these sort of walled gardens. They're enormously feature rich. They're full of a ton of different types of services, but they are, they really are like a mainframe. You sort of write to one and run on it forever, or if you have to re-architect, you're really running into real challenges. And it's good and bad. From a perspective of a user, it's great that Amazon has got lots of functions and features, but it also means that it's very hard to replicate and to test and to develop anywhere else. It's nearly impossible to take an application you're running there and move it to an environment where you don't have access to some of those Amazon features. And obviously, you're pretty well locked in onto these new platforms as you get there. I think when we started working on containers 3 years ago, 2 years ago, we were thinking that containers were really important. They were the first thing that sort of looked to us like they had the potential to really disrupt sort of this migration to these big mainframes and sort of get back to this idea that that part of the appeal of cloud computing was that we were going to have computing as a utility, that computing would be sort of globally available and you could plug into it like you plug into the wall sockets. And obviously that's not happening, right? I mean, every cloud has their own little container service that they use to run containers, and they're basically applying the same concept to containers they have to everything else. Take it, implement it, and build it as part of the mainframe, and build it in their own unique, specific, defined way. And it's no different if you look at Azure or Google or even OpenStack has like sort of their approach to doing containers. Everything is sort of packaging up a container structure as part of it. And I think in a lot of ways that's kind of a bit of a frustration to some of us who look at this and think, what, containers really aren't just another part of the stack. They're not just the cherry you put on this. Containers are bigger than that. They actually have the potential to fully redefine all the layers and change how we think of all of these different services. Because the reality is, most people are using containers today to sort of package up their applications, but we're well past that in a lot of places where containerized infrastructure services are beginning to happen. So in a lot of ways, the vision we want to talk about today and what we want to discuss is really it's going back to that core belief that it's not just the applications that are being containerized, but the blueprints and the way we actually orchestrate them are obviously being containerized, and these infrastructure services, all of this functionality we think of as being traditionally built in physical resources or built in a specific way for each cloud. We believe that all of these things can be layered over the top and can be delivered as a set of containerized infrastructure services. And that's a big vision. That's going to take some time to get there because many of these things today are, the reality is your storage is often an NFS server, or maybe it's a private thing from the cloud provider like EBS or EFS. But there's what we're seeing is the emergence of a lot of new companies and technologies that are containerizing these elements, containerizing persistent storage, containerizing your monitoring agents, containerizing the overlay networks, containerizing the database. And, we get, our belief is that as we do that and as we implement this and we make this incredibly easy, it will make it much easier for organizations to effectively consume raw hardware from cloud providers or from their own data centers in an identical way, effectively saying, look, as long as I can get, some CPU, a VM or a server, running Linux with an SSD and a fast network, and I guess this week now running Windows, I should be able to layer in everything else I need and deploy a full working implementation of my application stack and my infrastructure stack. So that's really the goal. And in 1.2, we're introducing in Rancher the concept of infrastructure services and an infrastructure service catalog. And the idea is that this catalog will be a little bit different from the application catalog that probably you guys have seen if you've used Rancher before, that's a part of Rancher. It'll really focus on managing and making available networking drivers and storage services and monitoring services and things like load balancers and databases, NoSQL services, key value stores, DNS services, all these different types of middleware or infrastructure services that you want to provision and deploy easily to any infrastructure that you have on any cloud or any bare metal or any VMware infrastructure you might be running. So, in each of these, there's often two elements to deploying one of these services. It's setting up the actual service itself, for instance, laying down an overlay storage service, or it's deploying the drivers that are going to manage that and orchestrating those drivers and making sure that the application stack knows how to access that storage. So there's multiple layers that need to be coordinated and orchestrated. So it's a pretty big challenge. It's something that we've been working on for a while, and we're really excited about. It'll take a while to fully realize all of these things, but we want to lay the foundations for them in this release, and I'm really excited to talk about that. So, Darren, I'm going to turn it over to you to talk for a little bit about some of the work we've been doing on networking, storage, services, because that's mostly what we're going to be going through today. Do you want to talk? I can flip through the slides if you just want to go through a couple of these before I hand it over to you for the demo.
Yeah. Sorry about that. So, in Rancher 1.2, so we're introducing network services, and right now, a lot of the work that we've done has actually been around CNI. There is some libnetwork support, but we've done a lot of work around CNI. The reason being that we're seeing a little larger adoption in CNI. Kubernetes and Mesos already support it, and in Cattle now we're going to support CNI. So what that means is for the kind of Docker experience that we give you with Cattle, all the networking will be based on CNI, so that we've actually plugged CNI into Docker, and then we'll be able to leverage any CNI driver or plugin. Just have to package it up for Rancher as a catalog entry, and then we can use it.
Can you explain what CNI is, just for people who don't know?
Oh, yeah, sorry. Yeah, so CNI, oh goodness, let me see, container.
Is it network interface?
So it's container network interface. Yeah, I'm trying to remember, I can't remember what I is. Now I feel stupid. Just Google real quick while everyone else is Googling at the same time.
Interface, I'm sure it's interface.
So, yeah, interface. Container network interface. So basically what CNI is actually it came from a CoreOS and Rocket. When they created Rocket, they needed to plug in networking. And so CNI is a interface to describe network drivers that a container system can use. And so it started in Rocket, and then it got adopted into Kubernetes, and now Mesos is using it. And it's really a very simple and elegant interface to do networking drivers. So someone like Calico or Weave, or if you have a proprietary vendor, or like VMware, NSX, is that what it is? Any of those networking vendors can just create a CNI plugin. They'll just plug right into like Kubernetes and Mesos, and so we've adopted that in Cattle too. So Docker has its equivalent framework, which is libnetwork. And so libnetwork is really only used by Swarm, and that we'll be supporting too. But we're seeing honestly a lot more drivers being developed in the CNI realm. So with the networking services, basically what we'll do is, like, if you're deploying Calico, we will deploy Calico itself, which includes like etcd and then the Calico agent that runs on the host. And then we also have this component, which is it's basically like a plugin manager that looks at what are the deployed stacks and see that this stack that's been deployed in Cattle is for a network driver, and then we'll go and configure Kubernetes or Mesos or whatever it is to be able to recognize this new CNI driver. And so we just dynamically do that when it gets deployed. And so we manage the whole, we manage the installation and deployment of the plugin itself, and then also the system too. Yeah, so Shannon, if you want to just go to the next one. So, and then additionally, we have storage services. And this is largely what I'm going to be demoing today, is what we're doing with storage. So basically, for Cattle, Mesos, and Swarm, they all leverage Docker volume plugins. And then Kubernetes uses Flex volume plugins. There's also, Kubernetes also has like in-tree plugin, like code that's bundled into Kubernetes. But those aren't very pluggable in the fact that you basically have to modify Kubernetes and get that upstreamed and built. And so Flex volume right now is the interface they have for external plugins that you can deploy outside of Kubernetes. And so what we've done in Rancher is we've taken, if anybody has any Docker volume plugin, we can package that up, deploy that, manage it. If there's anything, your storage system yourself, like if it was like Ceph or Gluster, we can also manage the full storage system. And so we'll install the Docker volume plugin, get that registered with Docker. And then if that storage system also has a Flex volume plugin, then we can also we can add that to Kubernetes. Shane, can you go to the next slide? Okay, so in terms of the enhancements that we've done around storage, because there's been a lot of work. Storage is honestly been really quite difficult to get right. There's a half myth about that you can't run persistent workloads in containers, and so it's kind of a myth in the fact that like if you launch a container, you can just mount a volume into the container, and that's just basically the same as writing to the local disk. And so that disk could be local, or it could be EBS, or it could be NFS. And so the reality is you can run persistent workloads in Docker just fine, like if you're just launching containers. The major issue you have with running persistent workloads is really around the orchestration systems. They basically, all the orchestration systems kind of started with the idea of these web workloads, or they're ephemeral, or handle failure, or you actually deal with a failure. And so basically, they would do things that just were not very nice to, you're running in a database, you don't want to just suddenly delete the database or the volume underneath because you just lost that data. So it honestly took a while within Cattle to figure out kind of the right approach of how to describe the storage and how to do the scheduling and how to do the scaling and whatnot. And I'll be demoing a lot of that today. But within the storage, so I was saying before, like we're supporting both Docker volume plugins and FlexVol plugins. And so if you have either of those, they'll just kind of work off the shelf. You just need to package them as a catalog entry, and then they can work. But one of the things we also did was the Docker volume plugins are a little like they require talking over a Unix socket with a kind of RPC mechanism, little HTTP JSON interface. And so we actually created a project to make Docker volume plugins even easier to write, because honestly what's been done with the FlexVol is really nice. You just basically you just create a binary that takes an argument like mount or attach, and then you just do whatever you need. It's a very simple interface that they did with FlexVols. And so what we did is we took that same interface and applied it to Docker, but we just enhanced it with create and delete, which are two lifecycle methods that Docker has that Kubernetes doesn't completely have right now. So I'll show that when I demo, but basically we created an approach where you can pretty much write something that looks very similar to a FlexVol, and then it just works in a Docker volume plugin. So we're really, the idea here was that we're kind of seeding the catalog with a couple integrations like EBS, NFS, EFS, some of the real popular ones that we've seen, but we obviously can't cover all of the storage systems, and so we'd love to see people write more drivers, and so we came up with a really simple approach to doing that. So beyond just the creating the plugin framework, we've also enhanced our storage scheduling capabilities, which is basically in order for us to, in Cattle, to put containers in the right place, we really need to know what the scope of the storage is. If it's local, or if it's available across the cluster, or even if you have something more complex where it's only available on certain hosts and not other hosts. So we need to know that about the storage so that we can place containers properly, handle failure properly. Also, once you've created volumes, how can the containers access the volume? Is it accessible from multiple hosts like NFS? Is it really only accessible from a single host like EBS or iSCSI? Or is it even just accessible from a single container? And that's something that we've ran into with virtual machines, like running virtual machines in containers. They actually can't share storage across multiple virtual machines, even though they're multiple containers. Okay, and then the last point is basically how do you manage the life cycle of the volumes? So, as you're deploying services and you're scaling your services down, what do you expect the volumes, to do? Like, should we automatically provision a volume for you? When should we delete the volume? If I scale to 10, do you expect just one volume that's shared for 10 services, or do you expect 10 containers with 10 separate volumes? And so basically, these are all the things that we've been adding to Cattle for the 1.2. And just a heads up, the Rancher 1.2 and okay, Shannon, next slide.
Next slide is your demo. I'm going to switch you over to make you the presenter.
Yeah. Okay.
You should have control now. Want to share your screen? See what we can see.
Yep. Let's see.
Oh, I'm looking at your screen. It's working.
Okay. Let's reload here. Okay. So what I'm going to be showing you today, I said Rancher, Rancher 1.2 is coming out at the end of October. So what I'm going to show you is very much still development. I know certain things are not going to work, but we really want to kind of show the entire kind of end-to-end experience. I'm having a weird issue with Chrome right now. Let me just switch browsers, see if I can get this to work better. Don't. But basically, so I'm going to be demoing, what was that?
Before we go on, there's a bunch of questions that came in while I was talking, and if you have a minute, I'd love to just go through a couple of them. One, yeah. Lori was asking, she said, so far I've only used the cattle networking. What are the advantages of using other types of networking?
Oh, right. So basically the cattle networking, so it's a tech, and we'll do but the intention of the networking is that it's just
Darren, your audio is breaking up a little bit. We're having a hard time hearing you just now.
Okay. Is that any better?
It's a little better.
If you want, I can hang up and dial back in.
No, I think it's okay now. I think it's okay now. We'll just stop there for a minute.
Okay. Okay, so our networking, the Rancher just built in networking. Kind of the idea is you really just don't have to think about it. It just comes up, it works, you get decent performance. It's fully encrypted unless you choose the VXLAN option. So it's, it basically handles I would say, kind of 80% of the use cases. But then there's things why you might want to deploy a different networking system like Calico that provides more advanced features. Like they have better QoS features or policy features. Policy is a big one, where you can have more advanced policies about who can talk to what, inbound and outbound traffic. Some other networking systems, will give you better integration with, kind of your data center. So if you're running on-premise, you might want to swap out our IPsec overlay to something that's like, a flat networking or a VLAN-based networking that just actually integrates with the data center. So it's kind of, I would say if you don't have the specific requirements, then what we have out of the box works fine. But if you start running into you want some other things out of the network that we're not giving, then that's when you basically start looking at different plugins.
Thanks, Darren.
Any other questions? Or
No, I think why don't you dive in? There may be a couple, but I'll hit it.
Okay. Let's see if this is working. I don't know. My Chrome just died on me today. Okay. Anyways, strange thing. Edge is working better. So the yeah. So I wanted to say this is kind of funny. When we I've had quite a few technical difficulties this morning, and right when we were about to start the meetup, we were about to go live. Like, okay, are you ready to go? And Shannon was just about to click the button, and then somebody tripped over the power cord on my laptop and chucked my laptop across the room. So I've been frantically trying to get everything back up and running through the beginning. So anyway, so what I'm going to demo is what we've done, so the new infrastructure catalog, and I'm going to go through a lot of the storage stuff. With this, in the infrastructure catalog, we're going to be, infrastructure services stuff, we're going to be adding networking and load balancing, and there's really a lot to cover. We're not really going to be able to, but I really wanted to show some of the storage because I'm actually pretty excited about it. Okay, so basically what we have is, before when you would say add environment, we would, I think I just have really bad networking right now. Okay. Before when we say add an environment, we would give you an option of orchestrators right here. Instead, what we've done is we've moved all of that into the catalog. And so when you go and you create an environment and you go into the environment here, open this up.
Well, this is early even for us to have demo problems.
I know. I was like, goodness, I just showed the create environment screen. Not even working. I think I might have to switch the network for this laptop.
Are you using the network?
Yeah.
It looks like it's connected up.
Yeah, we're just like running at a snail's pace.
Well, while you wait for your network for a second, there was a couple questions. One question someone asked was, will this networking stuff support VRRP? And I figured maybe you can talk about that while you're doing the.
So VRRP, no, not really. So basically, VRRP is fairly advanced and usually requires a little bit of like layer 2, which is a little difficult to get in the cloud. And so what I would say is, so we're introducing like new pluggable load balancers, and so I would see VRRP coming in as a new load balancer type. That would kind of make sense, a combination like well, it's basically a floating VIP, but we can, it would kind of plug in at that layer, but we don't really have anything for VRRP right now. That's what I would love to see. Somebody do, but honestly, we haven't had a huge amount of requests for it. Okay. Oops. Oh. Apparently, I've found out everyone, like, we're having problems in general with the network here. Okay. So hopefully you can see my screen again. Okay. So when we go and you create a new environment now, before we had this, add your first stack or add a host, and now we have this add infrastructure stacks. So in the catalog, before we would have, you can just go to the catalog and you can, oops, I don't have a host on this environment. Let me switch to a different environment that has hosts. So before you could go to the catalog and you can just add an application. So if I go to like the community catalog here, you can see all of the various, entries that we have there. A lot of these are contributed by the community. But so now we have this new infrastructure catalog. There's a little bit of an echo, Shannon. I don't know if you want to go mute. The infrastructure catalog, we wanted to keep the experience basically the same as the application catalog, because really it's very similar technologies and stuff. It's, we're just basically packaging up applications, but those applications have to be infrastructure service, and then we treat them slightly different, but we wanted to kind of keep this to a similar experience. And so here, if you wanted to install Kubernetes now, you would go and you would say, okay, like there's different categories up here. We can go for orchestration. I want to install Kubernetes. So you go and install Kubernetes the very same way you would install any other stack. One nice little enhancement we've had from a UX perspective is that we can now ask more options for Kubernetes. So like one of the popular ones we've been asked for is people want to be able to change the cloud provider for Kubernetes. So if they're deploying Kubernetes on Rancher on Amazon, they want to use the Amazon cloud provider to take advantage of more Amazon features. And so we'll be able to do that now, basically ask additional questions, and then also do more advanced things like change the scheduling policies of the services and whatnot. So just the same as we have like orchestration, we have here currently I have some of the storage drivers we have, but in this dropdown we'll have networking, load balancing, and basically everything from Rancher is going to be put into this catalog. And so really what happened is within Rancher, kind of the architecture and capabilities of Cattle, our orchestration engine, have gotten so rich that basically we can self-host all the functionality of Cattle and Rancher on our own orchestration system. And so what's happening is we no longer have kind of these special components we used to have, which was like our network router and our health check and our DNS. All of those are just being moved to services. And the advantage of that is once we move these all to basically catalog entries that you can install or uninstall, is they're all completely swappable. And so, if you don't like our out-of-the-box load balancing, you can add a different load balancer. Or, if you don't like the way we're doing health checks, you can add a different one, or even scheduler. Basically everything is going in here. Okay. So let me show you kind of how some of the storage stuff works. So I'm going to install the Rancher EBS driver. So when I go and I click this to install, for the EBS, it's going to ask for a secret key and access key. That's optional. If you're using an IAM profile, then you don't need to worry about that. So I'm just going to go and click and deploy. So once I deploy that, it's going to bring me over to this site here. So in stacks, we now have this section for infrastructure. So these are the infrastructure stacks. And one thing, let me just call out that I forgot to mention, was this is basically only visible to people who are owners of the environment. If you're not an owner, you're not going to be able to deploy these infrastructure stacks to it, because typically they require higher privileges because you are dealing with like storage and networking and whatnot. Okay, so you can see here, so basically we're deploying the EBS driver, and it's pretty much just deploying like any other service. Let me show you one of the really cool features that is coming in 1.2. It's already out there if you're using the pre-releases of 1.2, is the CLI. And so, like, as this thing's deploying, I can kind of, oops, not even on the right host, SSH. So I can see, like, here I'm just tailing what the service is, what's going on right now. And you can see, okay, it actually went down here, service instance. It created 3 new services. In this environment, sorry, I forgot to show you. In this environment, I already have a couple hosts set up. I have this one over here, but I've deactivated it. It's not, this is actually my laptop. But these 3 hosts over here are Amazon machines. Since I'm using the EBS driver, obviously it makes sense to be deploying them via Amazon. So you can see, so when I deployed that catalog entry, it went and it deployed out the driver. So I can see I have the driver running on these 3 hosts. Now, if I go to infrastructure, I can also go to storage, and it will show me, okay, here's Cattle EBS, like that driver, and these are the hosts it's attached to. Basically what it's accessible from. And let me show you basically how that was kind of like what that EBS driver package looks like. If you'll find this, so basically all of our storage drivers are github.com Rancher storage. So you'll find all the code for this stuff in here, and most of those, like EBS driver is right here. And I'll go over this in just a second, how to actually create a new driver if you wanted to. So, hey,
Darren, there are a couple questions. Do you have a second?
Oh, so I want. Sure, yeah.
Yeah, so the first question was from Luke. He asked if, when you're using EBS, are you limited? Typically, you're limited to a single availability zone. Is it possible to have a cattle cluster that spans availability zones and still uses the EBS driver?
So basically, you're still limited to, so once you've created that volume, you can't, since it's limited to an availability zone within EBS, we can't go beyond that scope or whatever. So you can't have an environment where, sorry, Shannon, there's an echo if you want to go on mute. You can go, you can create a service, service that spans availability zones, and then we'll create EBS volumes in each availability zone, but we can't move the storage across. So it's like if the service lands in one availability zone, we can create it there. If it lands in a different availability zone, we can create a new volume there, but we're not going to be able to actually move the data.
The other question about EBS was whether ranchers supported custom AWS endpoints, such as a proxy or an on-premise AWS cloud. This is, I know, some people that use Eucalyptus and stuff that we've talked in the past.
Yeah. We do not, but it is extremely trivial to support that. So since this is not actually out and we're still tweaking this, we can add that. So basically, so the reality is I'll just show you real quick. The EBS stuff, it's just a shell script. It's that simple to write these drivers, but it's just a shell script, and it's calling the AWS CLI. So you can see I've hard-coded some keys there. Don't worry, they'll be deleted afterwards. So it's just using the AWS CLI. So basically all it is really setting environment variables on the stack. So we can just change the catalog entry to accept the environment variables to change the where you're pointing to. As long as I hope AWS CLI works with custom AWS deployments like Eucalyptus. I imagine it does.
Last question was on the catalog piece. Robert asked if these infrastructure catalog entries are mutually exclusive. Can you have a catalog and Mesos in the same environment, for instance?
So the idea, what we did before, sorry Sharon, if you can go on mute. So what we did with catalogs before is that each catalog was per environment type. So if you did Kubernetes, you get a Kubernetes catalog. Your Mesos, you get a Mesos catalog. The infrastructure stuff sits below the orchestration frameworks, so this catalog applies to all orchestrators. Oh, maybe I misunderstood the question. Okay, let me finish what I was saying, and then I'm going to answer the question. I think. So but this catalog sits below the orchestration frameworks. So this catalog is basically it's available to every orchestration framework. And if the orchestration framework doesn't support the catalog trees, Kubernetes but doesn't work for Swarm, then there's just the ability to say it only works for Kubernetes, and then we won't show it available for a Swarm environment. But I think the question was actually more directly, I can deploy multiple orchestration frameworks at the same time? This one I go back and forth on because basically there's no technical reason why you can't. We have more done this from a UX perspective of making them mutually exclusive. But they actually all can run at the same time, and I do it quite a bit in development. So I don't really know. I think probably from a user experience perspective, we're still going to make it so you can only deploy one from the UI. I will tell you the CLI has less restrictions because we purposely don't validate as much because it's a little bit, you can do more advanced use cases from the CLI. So if you really want to, you can deploy 2 orchestration frameworks from the CLI, but I think the UI is going to block you.
Thanks, Darren.
No. Okay, so should I keep going? All right. So so what I wanted to show was basically, okay, so this EBS catalog entry. So we have a new catalog just for infrastructure stuff. So if I go into admin settings, you'll see there's a new section here for ranch infrastructure. If you want that enabled or disabled, I'm using a custom one right now. So this kind of shows you can disable our catalog, you can add a new one, or you can keep our catalog and add new things. And so you manage these infrastructure services just the same as you manage the applications in the catalog that we've done with Rancher in the past. Like the experience is basically the same. So if I go into infra templates here, Rancher EBS. So this is really the key, is like when you create a catalog, it has to be under infra templates as opposed to templates or Kubernetes templates or Swarm templates. Okay. Okay, so for EBS, so now if we look at what this is, so first we have our Docker Compose file here. So Docker Compose, this is, so this is our EBS driver. So it's just using our, basically the Rancher Storage EBS image, a couple environment variables. We set the global scheduling so everybody gets it. Setting up the access key and secret key if you want. So saying if we need to set up the, I don't know what it is, whatever the AWS URL environment variable, we basically just need to add it here. So it would be pretty straightforward to support custom. And then the last part here is the kind of the really important thing, is this special metadata. So we have this metadata for the storage driver. So basically once you have storage driver there, you see, like, we know that this is a special service. You need to give it a storage driver name. And then there's these 2 properties right now, which are what's the scope. That can be environment or local or custom. So the scope of local basically means the storage is only available on that host. And so that is basically, local disk, or if you're using like LVM, or some other thing, some special file system that you just mount kind of locally. So we just know that basically once we create a volume, it's only available on that host. We can't move it anywhere. Nobody else can use it except for on that host. So then we also have this volume access mode, which there's 3 different modes, which is basically single host read-write, multi-host read-write, or single instance read-write. And basically what that says is once a volume is created, who has read-write access to it? Can we have multiple hosts read-write to it? Can we have multiple containers rewrite? And can we have multiple containers read and write from it? So EBS, in this example of EBS, is basically, this is going to be cluster-wide. So that means that basically no matter what host I land on, or sorry, environment-wide, environment cluster is kind of the same thing. So no matter what host I land on, I can get an EBS volume, and if that volume is not currently attached to that host, I could attach it. But then if you look at the access mode is single host read write, which means that once I attach it to a host, it's basically owned by that host. So if there's a container using it, I'm not going to be able to move it. So let's say, like in a failure scenario, the host would go down, we would kill, like the host would go down, the health checks would fail in the container. We would basically say, okay, we need to delete that container and move the EBS volume over. And so we'll basically force attach it from that host and then attach it to a different host wherever it needs to be. And so these properties basically allow us to do proper scheduling. So this is kind of all the enhanced storage scheduling capabilities we put into Cattle. Okay, and then in your Rancher Compose is just basically the kind of the normal catalog entry stuff, which is a description about the catalog entry, and then any questions you need. Okay. So going back here, oh wait, no, this one, I'll take this one.
Hey Darren, is there a repo that contains like 1.2 work in progress docs on these storage drivers, someone that we can point people to?
No, I mean, the best thing is this repo right here, Rancher Storage, which you can see the development. So you can see how these, currently how the 3 drivers that we have right now, how they're implemented. I'll go through that right now. But no, we don't really have so much kind of documentation on the progress. Okay, so here's an example. So this is the EBS driver. So if I go and I look, actually there's some nice documentation already on how this works. But basically the idea is that it follows the flex volume interface plus create and delete. And so FlexVol defines basically, it defines 3 things. One is attach, detach, and it's not documented here. There's a third one called init. Init is just to initialize the driver if something needs to happen. Like we just call init once on start. But basically, attach means, like if it was, let's say it was iSCSI. Attach would mean, okay, attach the iSCSI, run, connect to the target or create an initiator, and basically create the block device locally. And then, oh, sorry, the EBS one doesn't have mount. Sorry, there's attach, detach, mount, and unmount. So once you do attach, you've attached it to the device, then there's mount, which you can mount the device. But the thing is, the way flex volumes work is both those are actually optional, attach and mount. If you don't have any specific logic you want to do for those, then there's kind of fallback logic. So like the way that EBS drivers work is all it really needs to do is attach the EBS volume to the host, which creates a device like dev SDA6. And then the mount logic, it doesn't have any. That will basically be handled by the framework, and the framework will basically format the volume and mount it for you. So let me just show you. I'm just going to go to that code here. So you can see, so this is the EBS. You can see the Docker is very simple. This uses the AWS CLI because I told you it's just a shell script. So basically, we're just copying storage. That's the binary for kind of the framework, which exposed the shell script as a Docker volume plugin. And so that will, so we're just basically copying in the framework binary, and then this is the actual driver, cattle EBS, and then start is just a wrapper shell script to start it up. So then if I go into the cattle, the shell script here, you can see at the very bottom, there's just basically, here's the different ones, like create, delete, attach, detach, mount, unmount, all the various arguments. You can see they just basically, like the shell script is just using like JQ and, to parse the JavaScript, and then it will echo out JSON. And if you want even more information on FlexVol's, Kubernetes has some examples. They have an LVM. That's ironic. Why am I thinking of this? Kubernetes. GitHub. So basically, they have in here in examples, volumes, FlexVol. So they have a little bit more information on how to write FlexVol plugins. And so the only difference between FlexVol and what we're doing is we've added 2 more options for create and delete. Basically, these ones here, create and delete, because right now in the flex volume interface, they don't have those lifecycle methods. Like Kubernetes 1.4 just came out and it has dynamic provisioning, but it's limited to certain drivers and it's all in tree. So the Kubernetes is still it's still a little bit of a work in progress, but kind of the full storage lifecycle. And that's why they don't have create and delete right now. Okay, so back here, and so I can show you. So going back to what we have deployed, so to kind of recap, we deployed the Rancher EBS driver. Basically, when we look at hosts here, we can see that that was deployed across 3 separate hosts. Now what I can do is actually invoke, it does just get deployed as a regular Docker volume plugin, and this is why it is accessible from Cattle, because we use Docker volumes, Swarm, because obviously Swarm uses Docker volumes, and then Mesos, you can use it too, because Mesos you can just pass in arbitrary Docker arguments, and so you can just use a volume driver. So let me show you quickly here, just kind of, again, I'm going to use the Rancher CLI. So what I'm going to do is I'm going to tail the logs of the EBS driver. So I can just say, okay, tail EBS. Okay, so that's tailing the logs of the driver. So you can just see that something's happening, because I'm going to be honest, it's going to fail. So it's going to create a volume, but it's going to fail. There's like just a little bug. So I told you this is all coming out the end of October. We're still kind of working out some of these things. Let me see the window I have here. Okay, so what I'm going to do is, again, I'm going to use the Rancher CLI. So one of the features of Rancher CLI, I can just get direct to, oops, host SHN. One of the features is you get
I lost you there for a second. What did you say? One of the features is what?
Oh, so one of them is you can just get directly to the Docker, like you can just call Docker directly. So, oh shoot, I think the network is again. I think there's a lag. Okay, so so what I'm going to do is, let's see this machine here, Darren demo 2. I'm going to interact with that one. So you can see when I run Rancher host, I was the host. I'm going to say Rancher -- host Darren demo 02, and I can just say like Docker PS. And so that basically that will just call Docker directly on that host. And it goes through like our secure tunnel stuff, so you don't have to expose the Docker socket. It's using your API keys and going through SSL and all that stuff. So it's a secure connection to that host. So one of the things it can do is, if you just say -- this basically will just set up a shell that has the Docker host set up properly. So now every Docker command I run is actually running against that host. So if you say, like, if I just do like, okay, let me just run a container here, like busybox, we should see, yeah, so you can see that started up on that host. Okay, so I'm interacting directly with that host. Okay, so now if I say Docker volume ls, you can see when I just did ls there, it actually said Docker list, the output of that script. And so I can say Docker volume create, I'm just going to name it foo, and then D is for driver. Right now it's called cattle EBS, and then I have to give it a size. So size, we're going to say 10. That's 10 gigabytes. So basically, we go like that. You can see it's calling that script, which actually just created the volume now, but you'll see it'll fail in just a second with, oh no, the create works, it's the attach that fails. But anyway, so I just went and actually created the volume. And I believe if we go over here, we should see, yeah, so we can see the volume has shown up, cattle EBS. We can see the volume here. It's in a requested state. What that means basically is it's not in use yet. Like, you created the volume, but you haven't used it, so it's not fully initialized. So it can mean different things, because sometimes if I just go here and I say like add a volume, technically what happens is you add like a volume definition, because we don't really know where you want that volume to be until the container is launched that uses it. So it's kind of like creating the definition of the volume, and then when it actually gets used, we schedule it to the right place. And so when I go and use this volume, it'll go to an active state. Okay. So you can see, so we're just interacting directly with the, just as Docker volume. So I'm just basically deployed a Docker volume. So the great thing now is, even if you don't want to use cattle or our UI or anything, this just basically gets Docker volumes up and running really easily. Now what I want to show you is basically what are kind of our scheduling capabilities. Both scheduling and kind of the service stuff. So let me create yet another screen here. Say user at all, but this bash on Windows is pretty awesome. Okay. So I have, I think, set up here. Okay, so I probably have that open somewhere. Okay, so we have a Docker Compose file. So one of the things here is immediately what you'll see is that this is a V2 format. So with Rancher 1.2, we are finally supporting V2. And to be honest, the reason why we've held off on supporting V2 is because we wanted to get storage, like storage and networking, those things kind of sorted out from a clustering perspective, because it's not as kind of straightforward as one would think. And you'll see that, so there's various options here. Okay, so there's basically 3 different ways to create a volume. One is you just want to create a volume that's at like the level of the environment. And so that's the equivalent of what I've done here. I've just created a volume called foo, and I want that volume to be used by containers. And so if I was to create a Docker Compose file, then basically what I would say is I want to use the volume foo. Like, so I'm going to mount, so you put the mount reference here, and then you define the volume, saying, okay, I want it to be kettle EBS. Actually, you don't even need the driver at this point. But basically what you're going to do is say external true. And so what that means is when you deploy this stack, it's going to use a pre-created volume. So this is kind of the simplest way to use volumes. It's very manual. Honestly, I don't see, I mean, there are use cases for it. Like one of the use cases would be if you had like a common place where you put like, let's say logs or something, like you had an NFS share of some common things or something like that that are accessible by lots of services. That might make sense for one of these volumes. And you can't always, mount them read only, just as a random point there. Okay, so that's kind of the simplest one. Like I just want to create a volume that's basically inside my cluster, and I want to use it. Okay, so the next one is, I'm going to change this back to data, is I want to create a volume that is used, I want to create a volume that's used, or like basically it's scoped to the stack. So when I deploy this, so I'll actually go here and say, okay, let me deploy this, Rancher Compose, we'll call it, I'm just call it stack 1, and we're going to bring that up. Okay, so basically, when I go, I got some debug logging stuff in there. Okay, so when I go and create that stack, so I can go over here. I can see, okay, this stack is coming up. That's activating. It's probably, oh, I had it set scale 3. Okay, so if I go back here, storage. So as I was saying before, oh, I can show you the errors here. As I was saying before, this is going to fail because I know that this driver right now, like I had some issues in the morning, so anytime it mounts, it's going to fail. As a little tangent, I can show you a feature that was just recently added. If I go and I click on a service, let's see, you can go to service logs, and you can see what's been going on with this. So you can see like, oh, we started off, we created those services, we're waiting for them to start. It timed out waiting from the start because something went wrong. But then we can say, oh, we actually got an error with the volumes. And so one of the big feedback you get, once you start deploying all these microservices and they're auto scaling and all this stuff, is how do I get visibility of what's going on? And so this service log really helps you out a lot. That's what I just earlier, just quickly, was this information is available from the CLI. When you do
You're breaking up there again. Can you repeat that last bit? You broke up.
So you can use service logs are very available to them earlier, and it's just basically when you do Rancher log. So instead of looking at containers, you're going to be looking at the service log. Okay, so a couple things here. So first off, when I go to
Darren, did we lose you?
Yeah, I'm having problems now, so it's lagging. Sorry. Hopefully you can still see. Can you see my screen here?
I can see your screen. I got a ton of questions, so whenever you got a second, I can ask you a few questions if you want to let your network figure itself out.
Yeah. Well, I got some questions. Hopefully the network will recover.
Well, about 10 people love the service log, so clearly that was a well-timed feature. I'm glad everyone likes that. There's a couple questions that different things that people were asking as things came through. One was, are there any plans to use S3 for persistent storage mounted as a directory? Simone asked that question.
Well, there's no reason why you can't do create a plugin, which would be would use the S3 fuse driver, and so yeah, you can do that. I mean, so the thing is honestly, there's so many different storage solutions. We're not like Rancher. We're not going to implement them all. That's why we kind of created a framework for this. Hopefully, we get some awesome contributions, and so I would see no reason why you couldn't do like the S3 fuse. And then mount that as a file system and then make it accessible to containers.
I think that kind of goes. Andrew Crawford asked sort of the same question, but about a Ceph cluster. He was saying, what's the current status for block storage backend with a Ceph cluster? I know Kubernetes has drivers to use Ceph. Is Rancher providing this in a formal way at the host level yet? Any thoughts on that?
Well, so if you are using Kubernetes, like Rancher with Kubernetes, you can use Ceph. I'm not 100. I believe there's a Docker volume plugin for Ceph. I have to look at that. So there are some options. So basically, you'll be able to package those up. Right now, like Rancher, we're not going to actually manage all of Ceph for you. But from a community perspective, if you want to take this on yourself, you can create a catalog entry to deploy all of Ceph.
I think that's a good point. I mean, like in general, we're going to try to support a number of different types of storage services that we maintain and support ourselves. But obviously, there's so many out there that we're going to rely on the community and vendors and other people to support these. So, we've been working with NetApp and EMC and they're supporting their, Rexray and NetApp versions of storage drivers. We've talked to guys like Portworx. I think they just contributed something into the catalog to do Portworx storage. So I think you're going to see a lot of different storage drivers, coming in. And so, given that there's already a Docker volume plugin and a FlexVol for Ceph, it's, creating the volume isn't the challenge. It's more, do you want to run Ceph over as a, kind of a software-defined storage on the same host as you're running the containers? In that case, then you may look at, you probably need to do the orchestration piece on Ceph as well. So that's the part we probably won't jump in. One of the questions I think Marcus asked, he said, will storage drivers make Convoy obsolete? That's a good question, Marcus.
That is quite a bright question. Yeah, so basically what we had done with Convoy, NFS, and whatnot, that will basically go away. Convoy was kind of a different approach on how to do like a storage framework. And so what we're doing now is kind of the next generation. I'm not exactly sure what we're going to do with the Convoy name, but what's going to be deployed with 1.2 is it's just going to be called Rancher, EBS, NFS, and EFS, and then any community ones. And so it basically, Convoy, the code base as you know today, is going away.
So there's another question that was kind of related to this. Brian asked, if you already have an existing EBS volume, can you mount that?
Yes, it's just a volume option. So it's when you create the volume, you can give driver ops. You just say volume ID equals EBS, and that basically what that means is we won't manage the life cycle of it. We just basically will use it, like we'll attach it, use it, mount it, and then detach it, won't delete it. Like so, in that situation, you created it, so you can delete it when you're done with it.
Another question that came in was from Peter. He asked, would it be hard to create an environment that anyone can connect, but he would see interact only with his stacks? Using shared environments would be a lot easier. So, this is a question you and I get and talk about quite a bit is, right now in Rancher, all of the when you create an environment, that's sort of the domain for control and for access control. But do you want to talk a little bit about the work that's coming on in that space? Thanks, Peter.
Yeah. So basically, so the Rancher 1.2 release is all about these infrastructure services, and then right after that, I mean, basically, we've already started work for this. We're wrapping up the development of 1.2, but we'll be doing a lot of work around multi-tenancy. And so right now, it's basically everything is in one environment. Like you have hosts in an environment, the users are in an environment, the stacks, everything are in one environment. And now that we're basically creating this separation of like user level catalog and applications and services and then infrastructure level stuff, is we're then going to abstract that even further such that you can set up an environment with resources in it where you set up all the storage, networking, and monitoring and hosts and everything. And then users can come in and create different environments, but then deploy to a shared set of resources. And so you'll get all the, from a user experience perspective, they can basically, someone can come in, create an environment and stack, and it just goes to some shared pool of resources. They don't see it, they don't know about it, they don't have access to it. And so what we're doing in Rancher is beyond just creating that experience, doing the user experience, the UI and stuff like that, we're also doing a lot of work in making sure that all the multi-tenancy is super secure.
Another question, I don't know if your network's back and smoking, but there's a question that came in a little bit ago from Alexi, and he said, what would be a high performance volume for, let's say, running a high load MySQL database in master clusters? Is there, what would you recommend for people that are starting to, play with running high performance databases and wanting persistent storage for that? Any ideas?
I mean, it's going to really depend on what the environment is. So if you're running in the cloud, so AWS and Google and Azure, I mean, they'll give you provisioned IOPS, and so you're basically going to want one of their provisioned IOPS SSD instances where they can basically guarantee you a certain storage latency. If you're running on-premise, then probably like an iSCSI-based solution would be great. I don't know, that one's really, there's a million answers I could give to that. It really depends on what environment. Yeah.
There's another question. Is the Cattle EBS service dependent on the Rancher server being up? And there's a couple more questions about HA that came in as we were talking about Rancher itself is HA. So, does any of this change sort of the inherent requirement of Rancher's management server to be highly available?
Right. So basically the approach that we take with everything in Rancher is if Rancher, the control plane goes down, that only impacts provisioning, which means anything that's already created and in use is fine. We're not in that data path. It's only if you want to create another one. So like if I deployed this Cattle EBS driver and let's say the core Rancher goes down, if I go and say like Docker volume create, it won't work because basically we're using Rancher as like the distributed state. We're storing information in there. But if I already had a container that was up and running using an EBS volume, it will continue to work. And so, this is actually very well tested across the board with Rancher and everything, is that, if Rancher goes down, all of your running services, everything still works fine. Those will not come down. You just won't be able to add new ones.
There was a question about sort of the scope of what might be in infrastructure services, and this was from Parthiban Srinivasan, and he said, do you have a roadmap to launch like integrated container security features like image approval, workflow, image vulnerability scanning, image cleanup, container IAM, these types of things? Would we see something like that as being part of the core Rancher, or something that would be more like an infrastructure service, or maybe something different?
Yeah. So basically, everything that was listed there would basically qualify as what we would say is infrastructure services. I think the easy way for me to think about it, just from like my background running production and stuff, is the infrastructure services really kind of caters much towards the ops or DevOps teams. Those are the software that they're going to be deploying, which is really around like managing, monitoring, keeping things up, providing core services. that stuff would be in infrastructure services. And then developers, more application focused would then just, interact directly with the whatever the orchestration framework is, or go through our catalog. And so a lot of like the security monitoring tools and things like that, or garbage collection of stuff, I see as infrastructure services. And another way to look at it too is if you also just kind of look at the list of all AWS services, the vast majority of those kind of fall into this category too. They're services that we're beginning to see as just available in a black box. A developer can just go and do this.
Oh, Darren, you broke up there a bit again.
Oh,
yeah.
I don't know what the last. what point?
No, I think maybe you just were finishing up. Okay, so there's guys. I do want to apologize. Someone just asked me about kind of repeated a question. I have about 40 or so backlog questions that are kind of on all sorts of different topics that I'm going to try and hold until we get through the infrastructure stuff, so we don't go too much longer. Darren, do you want to keep moving forward with your demo? How much more do you want to demo here?
Yeah, I got probably about 20 more minutes maybe. Okay, so I want to go through. So what we had done here before kind of networking, I think things are running a little better now, is we deployed this stack, which basically we said, okay, we want this volume called data, and it's going to be at the stack level. And so you can see from the Rancher UI here what happened is it created a volume called stack1 data. Now, if I go and I look at, oh wait, I stopped it. Let me bring it back up, because it's just doing, because it doesn't actually work. But what we'll see here, so basically we created that volume, and we're going to, from a zoning perspective, we start all, implementing what you would ask for.
Your audio broke up one more time there. So we couldn't hear anything you just said.
Shoot. Okay. Yeah. Yeah. I was wondering if I should dial back in, because I'm actually on Wi-Fi.
Yeah, maybe because it's gotten pretty bad the last 5 minutes.
Okay.
Well,
let me
questions that came in. I can answer some of them.
Okay. Yeah. Perfect. Okay. All right.
Hi, sorry there. I think I was muted while I was talking. I was just saying there was a couple good questions that came in, so I'll try and answer a few of these questions. One of them was, while we wait for Darren to reconnect on his network, one of them was from Alexi, and he was asking, what happens if the MySQL database of Rancher crashes? Is it able to recover everything from a fresh Rancher server reinstall? And I think there was a couple other questions about this. Darren kind of briefly talked about it. But you can deploy Rancher in a high availability mode relatively easily. It's part of the admin section. You just click on the admin tab. You'll see there how to deploy it, and you can run Rancher itself as a distributed mode. The backend, the SQL backend, obviously you can run that on a standard MySQL database or any other kind of backed up MySQL database, or you can use cloud hosted MySQL databases. So there's a number of different ways to make that resilient if you'd like. But typically, even if the system goes down, you just recover from any kind of a backup or anything. You shouldn't have any impact from that. Okay, Darren, you back?
Yeah, I'm back.
Okay.
Okay, so yeah, hopefully this works better. I didn't realize that it apparently was using the Wi-Fi to do the calling. So So what we had deployed here is we had deployed this stack, and what I was trying to point out here was it created one volume. The definition, going back to this stack definition, was we want this volume called data, and because this is EBS, it creates the volume and it attaches it to one host. It's only accessible on one host. So as we're deploying these containers, which are failing, but we're deploying the containers, it's all going to one host, because basically we're looking at scheduling and saying, well, we can only put it on that one host. So now if I go in and delete this stack, here. So if I just go and, so this is the stack that's failing to delete, or failing to deploy. Okay, so if I just go and delete this, so this will start the delete, and basically what will happen is, because that volume was created as part of the stack, when we delete the stack, the volume is also gone. So the life cycle of the volume is attached to the stack. Okay. Let's delete this one. Okay, so the next level of kind of scaling is, so this approach, what I showed for the stack level volumes, is actually going to be, it's probably one of the more popular approaches for like something like a web application, like WordPress or PHP or something like that, where you would put the content on a share, and then you can scale up your application across servers using like NFS. So like EFS and Amazon works real well for this. So then the next way that we can scale is, instead of actually having one volume per stack, is you can add this option here, per container. Now this is a Rancher-specific extension to Docker Compose, so this file won't work directly in Docker Compose. Is we can say per container. And so when we do this, what we're saying is, as we scale up the service to like scale 3, we want one volume per container as we scale them. So if I go, let's see here, okay, we'll just call this stack 2. Okay. Okay, that's coming up. Okay, yeah. So you can see here. So basically, what we've done is we've created 3 different volumes. So it says like stack 2, data. That's the name of the stack, and then this ends up being the UUID of the deployment unit. It looks a little ugly, but basically, so as we've scaled up the service, we're getting one volume per container. Now, this approach works really well with persistent services, like persistent applications, whatever, that manage their own replication. So this would be things like etcd, any type of NoSQL or key value store, like Mongo or Redis or whatever, that they're basically assumed to be running multiple of these, and they're just writing to local disk. And so this becomes really powerful because you can do something. Let me just delete this since it'll just keep churning. What you can do is you can do something like deploy etcd with this approach. And you say, okay, actually, I want to store etcd on an EBS volume. And then there's other options for, like, you can actually say, like, I want, this provisioned EBS volume or provisioned IOPS, so I want a fast one or whatever. And so if we scale up the cluster to 3, then you can get 3 separate EBS volumes that get attached to 3 separate hosts, to the 3 services, 3 containers that are running etcd. And then if you do, let's say, something like an upgrade, we won't actually destroy the volume if we don't have to. Like, there are situations where we need to destroy the volume because the host went down, and it's like locally attached storage that we can't move. So like in that situation, we would actually make the decision of destroying it and creating a new one. But if we don't have to destroy the volume, we won't. And so for something like like etcd, if you want to do an upgrade, so when you do the rolling upgrade, it's basically just deploying a new container, starting up etcd. It uses the existing data. And so this works great. Like, we've seen this with Zookeeper, so people can manage Zookeeper pretty efficiently with Rancher. And so while something like that will rebuild its data from scratch, if you're having gigabytes or even more data, you obviously don't want to rebuild it if you don't have to, and so it makes the upgrade process like more seamless. So I think that basically concludes what I want to demo for the storage. So basically went over the how to create the storage drivers, how those actually work, some of the code there, how some of the scaling works, and then how it works in the Docker Compose and V2 format. So again, all of this, you'll start seeing the storage stuff. We'll be making it into the 1.2 pre-releases over the next 2 weeks. And then we'll be rolling all the storage out, then all the networking, and then so basically 1.2 is going to be, the full 1.2 will finally be released the end of October.
Awesome, Darren. Thanks for going through so much. I have a long list of questions that have been pouring in, so we can try to jump into these. And be patient, guys. I'll try to get to everything. I know someone had noted they were hoping to see EFS, but how different is EFS from what you showed already, Darren?
Oh yeah, I mean, so I just picked EBS as one of them. So we do have an EFS driver. EFS, the way it's going to work is basically you can pass in a file system ID, and we will use an existing file system. Or if you don't, then we will create a file system for you, and then we'll managing the lifecycle. We'll delete it. So setting it up, deploying, everything is going to be the same as what I've done with EBS. The big difference, of course, is that EFS is NFS, which is shared across hosts. So it's going to, you're basically going to be able to scale services across hosts and stuff. But the EFS integration is actually super nice because especially if you're using IAM profiles for the hosts, because there's just almost no configuration because it'll just go create a file system and then scale up your services, and so it's really nice.
Awesome. This question was from Abhinav, and he said, so with the storage driver per container, is the need for a side kicking the data volume going to be gone?
For the most part, yeah. So basically, it's interesting as we started looking into, because Rancher, we've actually had support for creating volumes and using Docker volume plugins, stuff like that, for quite a while. But when you looked at how to scale a service, the data volume containers ended up giving you a little bit more flexibility in certain things. And that's where this per container basically came from. And so the data volume approach was a cool approach, but it's honestly, I think it's a little harder to explain to people when they start and come into Docker. And so what we wanted to do is be able to keep all of the functionality as much as possible of what you can do with that, but then do it with volumes. And so volume seems to be a little bit easier to grasp concept. And so we would hope as this gets richer, that data volume containers will go away. And then on top of that, I just wanted to point out that we're adding functionality. I'm not sure if they'll land in 1.2 or not, but it's when you deploy a catalog entry, you can change some of the options of what you're deploying, and storage driver will be one of them. So you can put a catalog entry that by default might use local storage, but when you deploy, you can say, oh no, actually I want that volume to go on this provisioned IOPS device, iSCSI or something like that.
Yeah, that actually addresses one of the questions, or not really a question, but Christian Tofik, who had created the MariaDB cluster design in the catalog, was saying that how much is this going to, with these new 1.2 storage services, it looks like we're going to have to kind of reconsider some of these, but it sounds like you guys kind of thought that through.
Yeah, and so, I mean, definitely whatever you were doing in the past, it all still works. We're just trying to make it simpler and better, and give you a little bit more capabilities and whatnot.
There was a question from Robert. He had, when you were showing destroying a volume, is it possible, or does a backup get made before something gets destroyed? What happens with destroy? Is there any opportunity to back things up beforehand?
That's basically up to the storage implementation. We are adding, I'll show you here, you probably won't see this in the 1.2 release, but you do see backup targets here. But we do have snapshot and backup lifecycle management in Rancher, but then it depends. It depends on some hooks and enhancements in the driver to be able to handle them. So those things I think are going to come like after 1.2, and then so basically it will be like, because right now we have like in our plugin interface, there's Docker volumes. Okay, hold on, there's basically flex volume is like the base, and then Docker volume adds more functionality, but nobody has the concept of like snapshot or backups. And so basically, for that functionality, we have to make it Rancher specific because there's no kind of standard approach out there yet. And so it's going to be, Rancher specific enhancements to those Docker volume plugins to support that.
Yeah, there was I think it's kind of similar, but Thomas Hansen had asked a question. He said, do you see data volumes as a good way of isolating the storage from the rest of the services in a stack, making it easier to upgrade individual services?
Yeah, for sure. So, I mean, because there's a lot of applications that, they use persistent storage or kind of like semi-persistent. Like there's things where it's like you don't, if you lose the data, it's not a big deal, but like maybe it's cached information, or you just don't want to necessarily lose it or have to rebuild it. And so it can make like upgrade and things more seamless and better. And so we do try our best to, like when we do an upgrade, to use the existing volumes and things.
There was a question a bit earlier that Alexi asked, and I've been trying to get to it for a while, but he was saying it was sort of about auto-scaling, and he was just asking if there are any plans to make scheduling similar to the way Amazon Elastic Beanstalk works, that is, basically launching more instances when resources are close to specified thresholds. Anything? I know there's some stuff going on right now in that area. Do you want to just talk about it briefly?
Yeah, so basically, we've started working on auto-scaling. So this would be yet another like infrastructure service. So you'll be able to go in there and say, okay, I want to add the auto-scaling capability, that you'll be able to put metadata on the service of how it should be auto-scaled, and then the auto-scaling service will look at that and then either scale up the service, like add more containers to the service, or add a new host. The adding the new host functionality does require that you're using our Docker machine integration, not the custom host, because a custom host, we don't know how to spin up another one. But so if you are using the Docker machine integration, then we can just spin up more hosts. And so it's been a hugely requested feature, and the development has started on that. It won't be in 1.2, but it's going to be a catalog entry. So it's actually not even going to be tied to a Rancher release kind of window, because we can just basically deploy it as an external thing.
Great. All right. Thanks. One of the other questions that came in was, will catalog items or other, existing templates that users have with Docker Compose v1 still work? You talked about supporting v2.
Yes, of course. Yeah, so we will continue to support v1. I'm still a fan of the simpler syntax of v1, and so we'll continue to support that indefinitely. It's just if you want to use volumes, and then there's some networking things, and we're going to do some other cool things with the v2 format. So if you just want to use the new features, then you have to use v2 format.
Right. And Andreas asked, how much of what we're showing works in a network gapped environment? With Cattle, he was saying he can override the image names to go local, for instance, but they weren't able to do that with Swarm on 1.1. And so how much of what we're talking about here would work in network gap?
So when you run it, one of the complexities we ran into with the air gap networks is that what we did was we made it so you can basically configure what the Rancher base images are. There's pretty much just two of them. There's three of them. Rancher server, Rancher agent, and agent instance. And so before we just had three of them, and so we made it so you could basically configure those. And so people could pull the images down, upload them to a different repo, and then you're good to go. And the configure rancher, use those. But with the explosion of the catalog, it's gotten much more difficult. So what we're doing is we're kind of adding a catch-all feature that anything you deploy, let's say I say like Docker run nginx, it will just prepend a registry to that. So whatever is it, like, so if in the catalog it's like, say rancher storage EPS, like that's our image, you could pull that and push it to your custom registry as rancher storage EPS, and then configure rancher and prepend it with that that registry. So it's honestly not the most super flexible approach. It's basically saying 100% of the images that rancher is going to pull are, well, it's not 100%. Basically, if nobody specifies a custom registry that they're going to pull it from, we're always going to prepend this registry. And so I believe that's going to work well for air-gapped. And so we're doing that feature basically because we have customers across the world, and not everyone has good access to Docker Hub or the central Docker registries or whatever. And so we've done that feature. So I believe that should address your use case, but it does kind of require some manual pushing and pulling images and whatnot.
Yeah, I think it did. He said that sounded perfect. So there was another question that Christian had, and he said, how does Compose v2 conflict with Rancher Compose? And since Rancher Compose seems like this has some of the same features, that now come out of the box with v2, are we changing anything in Rancher Compose?
No, so what Rancher Compose has always been was like we really like Docker Compose, and so where Rancher Compose came from was that we started with Rancher doing multi-host and all these things before Swarm existed, and so there was no multi-host deployment tool, and so we really like the Compose syntax. And so what Rancher Compose is that we've adopted the syntax and semantics of Docker Compose. But we do have our specific extensions. So like with v2 coming out, nothing really changes, but so they came out with v2, we like Docker Compose, so we adopted the same syntax and everything. But Rancher Compose really is different from Docker Compose, because Rancher Compose talks to basically Rancher and cattle to deploy things. Docker Compose talks to Swarm. And so go and you deploy, so with 1.2 we're adding SwarmKit support. Right now we have like Swarm, which is the old Swarm. Now there's the new Swarm, which is SwarmKit or Swarm mode, whatever you want to call it. So if you go into Rancher and you say, I want to create a new environment and I want to deploy SwarmKit, then you can just use Docker Compose, because Docker Compose is the tool for Swarm. It's similar to like if I deploy Kubernetes, I use kube control to talk to Kubernetes. So it's kind of like Rancher Compose is for cattle, Docker Compose for Swarm, kube control for Kubernetes. It just happens to be Rancher Compose and Docker Compose use the same format because we like it.
Awesome. Someone asked a question about Convoy. He said, I've just started looking into Convoy, but since it's on the road of deprecation, is the major difference between volume drivers and Convoy that is a core cattle function versus a separate agent? Do you want to just talk a little bit about sort of the, if someone's using Convoy or what the options might be?
Yeah, so basically the difference between Convoy and what we're doing now is that Convoy was really a standalone product in itself. And with what we're doing now with the Docker Volume plugin is there's kind of two levels. Is one, we're just managing Docker Volume plugins and FlexCall plugins. So if anybody has one of those plugins, we can use it, manage it, deploy it. But to make it easier to create these plugins, we then additionally created a framework, but that framework is tied to Rancher. It makes it easier to create Docker Volume plugins in Rancher. And so that's kind of the big difference between Convoy and what we're doing now. Was Convoy was intended to be completely standalone. Rancher is tied into Rancher. And the reason why we did that is in order for Convoy to progress, it needs a lot more distributed state. management and to handle failover and all these different things. And honestly, it's far easier to just do it from Rancher because we already have that visibility to everything. And so what it ended up being is the drivers are just really super simple because we can leverage a lot of the core functionalities of Rancher. So we basically, kind of took that approach. So if you're using Convoy today, that will continue. It's not like we're deleting it or anything. It will continue to work for a while. We'll continue to support it. But it is kind of deprecated, so we have a new approach. And so over time, we hope people will move to this new approach. And the new approach easier to manage, it's more flexible, and obviously it's more reliable too.
There was a couple questions Holger asked earlier, Holger Winkelmann, and he was wondering, do we have any plans, or are there anything you know about a new Linux LVS GORB-based load balancer? Anything you can comment there? Looks like there's a thread he attached from GitHub.
Right. So basically, okay, we take this kind of two-level approach now with Rancher of we make it so that anybody can deploy a service to provide some function, and then we also create a framework to make creating those services easy. So an example would be like what we did, because basically this whole approach and design really started with what we did with DNS, was we made it such that we could externalize the DNS management. Like if you wanted to deploy a stack, but you wanted those services to get an external DNS name from like Route 53 or some DNS provider, we made it such that you could deploy that as a standalone service. So we created the external DNS service, which then had a plugin interface in itself so that people could go and then create more implementations of that. So it's kind of, there's two levels. It's like if you want to take over the whole thing, or if you want to use our framework and then just change a little bit of code in it. Okay, so we've taken that approach with basically everything now. So we did that with storage. That's what I'm demonstrating here. And we're doing the same thing with load balancing. So load balancing is now being completely externalized. It's like from the core system, a load balancer really is no different than a service, because the reality is we're just running HA proxy containers, and the health checks and management and failover and deployment and networking, it's all just core functionality, but just done in a very specific way for a load balancer. So we've created this load balancer service, which has our HA proxy implementation, but it has a driver interface in it. And so we've designed this such that we really hope that people will find it very easy to add traffic, or so I missed the name of that, but I assume it's the Google.
The GORB, yeah.
Yeah, that's a really cool project. Like I really like IPVS. It's super fast. So we're laying the foundation so that people can do these things. And so I mean the reality is what we find, like there's just far too many of these. And, like we can't do everything ourselves. And so we're leveraging kind of the power of the community, and we've seen this work really well. Is that if we just give people simple hooks, they can go and implement them. So I really hope someone can create a load balancer within our framework to do that. And then on top of it,
Traffic have been working on some stuff already to do this, and there's already traffic in the catalog, so that'd be another great one.
Yeah.
It's cool to see it sooner rather than later. And that actually brings me to Robert's question, and maybe a good point to sort of.
Sorry, I just want to follow just one thing. It also with our load balancer is our load balancer is plugged into the ingress controller in Kubernetes too. So if you implement one of our load balancers, it works in Cattle and Kubernetes, just kind of out of the box.
Cool. So this question was from Robert, and he was, and there's a couple more questions kind of like this, but he was just saying, we talked a lot about storage today. What is the 10,000-foot view of the timeline for other types of infrastructure catalog, and other infrastructure catalog types, networking, load balancing, other types of services, security services?
Yeah, you're just going to see a huge amount of things landing in the next month. So basically what's coming in 1.2 is storage, networking. So networking, we will have the Rancher IPsec VXLAN. We're really hoping to get Calico and maybe some others. I'm basically just going to say, give you the end goal, like the end date, which is the end of October. these things will be streaming out over the next couple of weeks. But I don't know the exact schedule over the next couple of weeks. But so from networking, we'll have that. From load balancing, we'll have the load balancer service, which is just HA proxy, and then hopefully we can get some people to do traffic and others. Our DNS management will be externalized into a service. Our health check is too, although I'll be honest, that one is not like the simplest one to replace. But if somebody does want to implement their own custom health checker, it is possible. What else is the other things? So basically,
can you envision someone having like another scheduler as an external thing, like say Nomad?
Right. So that's another thing. So in 1.2 is resource-based scheduling, and resource-based scheduling is a service too. So what we've done is, what we have today within Rancher is very, it's like tag-based scheduling, affinity, anti-affinity. That type of scheduling we're kind of keeping in the core of Rancher, but then for resource-based scheduling or additional scheduling decisions, we're then externalizing that to a service. And so in 1.2, we're going to be doing full resource-based scheduling. I think right now we're just starting with CPU and storage being the kind of the key one. But that is going to be just a service in the catalog. And so if somebody wants to swap that out for their own, then you can do that.
Awesome. And any plans for Contiv? I heard there was a question. Are group-based Contiv policies on the radar? Flocker on the radar? Weave was up earlier.
Yeah. So they are. Like, and I already know there's like some specific projects we have in the works around Contiv. I'm trying to get that in because again, Contiv they have both CNI and libnetwork drivers, and so it's just basically just getting that as a catalog entry, and then you can deploy that, and then the policy management is going to be basically up to Contiv. Like, we're not, our general approach is we don't try to create an abstraction layer or anything. Like, if you want to deploy that product and use it, then you use it, and so we'll make that available.
There's another question so this is kind of, when I move to 1.2, what happens after an upgrade if I have working Convoy NFS volumes?
Nothing happens. So what's going to happen, because 1.2 is such a massive release, and we've refactored, before we had all these things which were kind of baked into Rancher, and now they're all being exploded out into all these plug services. Is what will happen is when you upgrade, you're basically going to have kind of a legacy environment, and then you can create a new environment that can take advantage of all these services. After we release 1.2, based on demand and customers and whatnot, we will look at if there's a good migration strategy. We've, for the vast majority of our users, we've seen that they don't mind so much if they have to rebuild an environment, but we'll see.
Okay. There was another question, on more the networking services side. Marcus was wondering, is it going to be possible to have a concept like OpenStack floating IPs, to have some IP-based network service, highly available? Darren, you still there? Oh, I think Darren's network, or you're muted or something. We can't hear you. It looks like we lost Darren. I'm not sure. Maybe his phone went dead, or we lost the section. There was a couple of questions that came in while we wait for him. There was a question that Thomas asked, said, is there any work being done to make the setup of Rancher in HA mode easier out of the box with a load balancer? And the question is, the answer is actually, yeah, there is some work being done there. There's also a number of people who have sort of come back to us with some suggestions to improve this. One, we just had a meetup here in person, actually, in the Bay Area, and Align Tech presented some really cool stuff they've done to just sort of make it one-click deployment of an HA Rancher implementation. So we're going to try and take some of that and bring it into the community, and hopefully make that as easy for everyone as they sort of had implemented. They had to do a couple of sort of heavy lifting things. I mean, the big part was sort of injecting the kind of the initial database and some stuff that we typically require before an HA mode. So love to make it easier, and it looks like some people are doing cool stuff to make it easier. Hold on a second, let me just get this one. There was a question. Oh, someone was asking about next week in Berlin. So we're going to be in ContainerCon in Berlin next week. If anyone is in Europe and they're attending, we'll be demoing all of this fun stuff and chatting. So Christian, it looks like we will see you there. Another question that came up. I think Darren, are you back on the phone at all? Looks like we still haven't recovered his voice, so hopefully he'll rejoin in a second, and I'll get him. Well, another question was about other events we're coming to. Yeah, we'll be at reInvent. Lori asked if we were going to be at AWS reInvent. We always tend to go to reInvent. We'll be at KubeCon up in Seattle. We'll be in Berlin at LinuxCon. We were out in Toronto recently. Plus, we're kind of everywhere these days. It feels like speaking or attending. So we're even going to be in Marseille next week. We've got. Ivan reminded me that we'll be in Marseille next week at the French D-Day DevOps Day. So, yeah, we're lots of different fun places. Darren, you back? I think I just heard you pop in.
Yeah. So I guess I got dropped there. I don't.
Okay, no problem. We were just answering a bunch of questions that we're in and talking about all the different events we're going to be at in the next couple of weeks. So there was a couple more questions that I was hoping to have you answer. One was about hold on, let me pull this one up. Is it possible to have we were talking about the floating IP one. Did you get that question?
No, I didn't.
I don't think you did. So my question, Marcus had asked, is it possible to have a concept like OpenStack's floating IP, to have some IP-based networking services that are highly available? I thought it was a good question.
Yeah, so we don't have, I mean, one can definitely build like a catalog entry to do something like that, but from a rancher perspective, we're not going to have any visibility to that. It's something we've thought about, but I haven't quite come up with what's the right like approach or abstraction there. Because basically, when you're deploying, this ends up being like how do you do like really super high availability stuff? This is kind of like the last mile. Is you usually need a floating IP or some type of lower level infrastructure to give you a highly available entry point. It might be Anycast or something like that, and so we're not quite there, but it is somewhat on the radar, because we do know that like right now we're basically just really relying on the infrastructure provider to do that. But in kind of our grand vision of the world where everything's containers, we can just manage everything. We know it's something we need to do.
Okay, another question kind of on the same topic Marcus asked, is it possible to have specific routing table namespaces per Docker container / rancher stack, so you could implement like a virtual router?
Yeah, well, so I mean, that starts getting into kind of like the flexibility of CNI, and why we like CNI is that all of these, so the thing is the best, I found the best way to kind of describe, abstract, or orchestrate networking is really just keep it high level and don't get in the middle of it, because there's a million different ways to do networking. And so the CNI approach allows you to do that. And so it's, if you're savvy and you understand these things, it's not that hard to create a CNI plugin. And then it does have the ability like of setting custom routes and whatnot. And so when you get into these more advanced things, we can do that. And so, for our own customers, like our rancher customers, this is a lot of the stuff that we look at, because we're deploying rancher on premise and crazy legacy environments, or they have these requirements are just odd, and we can address these by doing all these kind of one-off configurations. So it's all basically going to be possible.
Cool. There was another question. Peter asked. We were talking about load balancing, and he was saying, right now the load balancer service in Cattle can use certificates from the certificate tab, but it's the only service which can use it from what he's read. Does enabling additional load balancers allow you to use these certificates and can use them with other services? Anything you can talk about there?
Yeah, so the certificate management is kind of tricky because once you upload a certificate to Rancher, we don't really want to expose it. Like, we don't want you to be able to download it because it's a private key. And so because of that, we haven't made it possible for people to get access to those certificates except for the load balancer. And so basically this does follow suit that, like, if you create a load balancer service, we will give you access to those certificates. You can get them directly, which is like a fabulous backdoor if you think about it, of like, well, I could just create any service and call it a load balancer and get access to the certificates. But again, like, you have to have escalated privileges even to deploy these to begin with. Like, you have to be an owner of the environment and everything. But I don't know. We keep going back and forth to get so many users who say they just want to be able to access certificates. So I think the approach that we're going to take is it's just going to be a flag. When you create the certificate, you say whether or not you can read it. And then I think that should probably make most people happy. And then at that point, you can write any old service. It doesn't have to be a load balancer one, but you can write any service to get a hold of the certificates.
Okay, a couple questions. Since we're on the topic of load balancers, I have seen people chain ELBs with a Rancher load balancers to get around certain security issues. Is the external load balancer ELB feature still in for 1.2?
Yes, and I believe we just launched ALB support. I'm pretty sure it's in the catalog. Shannon, do you actually know if we push that out?
Yes, I believe it is. I'm 90%
yeah,
sure it is.
So the external ELB and ALB integration is really quite independent of the Rancher managed load balancer, which is like a service level load balancer. Like, so we look at the external load balancer as more like an edge load balancer. We really just need TCP, a highly available TCP load balancer. But then like layer 7 SSL and all that stuff, we can manage ourselves. Or you can still manage it with DBS or whatever. So that it's not going anywhere. That's still staying there.
Cool. Let's see. We're guys with loads of questions. I think we've talked about all the main latest Rancher enhancements. We talked about service logs briefly and kind of tinkered with them. We talked about some of the main things that are coming, like Docker Compose v2 and storage. So let's skip that for this week.
There's one question on here I want to answer. It says you showed the driver setup via the CLI. Can we see how it's done? Oh wait, no, the driver setup via the CLI. Oh no, I actually don't understand that question. I thought it was the opposite.
Oh, I think it's Lori was asking if there was a way to configure the storage volume drivers, from the GUI. It looked like you did it through the CLI.
Well, so it's basically because you can deploy everything through a GUI. The configuration of it, like that YAML file, is like the CLI because you have to basically create the catalog entry, which is setting up the configuration files. But then you can then deploy it from the GUI, which is what I just showed of just clicking and deploy. But what I wanted to point out is that what I did from the GUI, you can also do from the command line. You can deploy catalog entries from the command line. That's possible with the CLI that's in 1.2.
Does that answer your question? I don't think we have time to show it. Unfortunately, Lori, we're kind of coming up on 2 hours now. But seriously, last month we weren't here, and the whole meetup lasted like an hour, 45 minutes. This is ridiculous. Okay, let's see. All right, so a couple questions that probably worth kind of hitting before we leave and wrap up, or we won't leave till all your questions are answered. Don't worry, we never do. But a couple more want to jump into, and then we can kind of maybe wrap up, and we'll kind of finish the rest of these after, as people drop, if they still want to hear the answer to their question. This is one that came from Adam, and he said, with Convoy we can specify a volume name, and it creates the volume in the Convoy cluster. Will that be possible with the 1.2 storage services?
I'm not sure I don't know if I fully understand that. So
as opposed to manually creating the volumes via the CLI. Does that make sense?
Well, so depending on how, basically it's depending on how you set up the service, we'll create the volumes for you. So you just give it a name, and then as we deploy the service, we create a named volume that, might be like stack underscore name. I don't know if that's answering the question. I don't think I fully understand it.
Adam, do you want to, oh, yep, that's what he was asking, so you did answer it correctly.
Okay.
Okay, is another question, this was from Abhinav, and he said, it'd be great to populate the same UI as the catalog question UI while editing the service started from catalog instead of all typical options. I think I understand this question, but does that make sense to you?
No, I don't quite get it.
So I think he's
See if I can find that one.
So like it would be able to, I think it would be great to be able to edit. My guess is when you edit a service, it would be great to be able to modify all of those catalog questions that were asked. So I've launched something from the catalog. I maybe specified a piece of input like, the number of Redis nodes. But now I go back to this item. It would be great to be able to edit those services started from the catalog instead of, all of the just typical options that you get. So kind of being able to not just,
okay, so
edit it.
Right. So in 1.2, basically, what it is you can pretty much upgrade to the same version. So you can, after you've deployed something, you can edit the answers that you had put before, and that will basically kick off an upgrade to the same version.
Okay, got it.
And then it only upgrades what's actually changed.
All right. There was a question from Mario literally an hour ago, I think. So Mario, I apologize for how long it took to get this, but he actually called out Vince. He said, Vince, that mentioned that version 2 of the API, the Rancher API, may or may not be released with 1.2. Any updates on that, or do you just plan to extend the V1 API for 1.2?
No, 1.2 will have the V2 API. So right now, if you use one of our pre-releases, there's V1, and then there's a V2-beta. And so we put the beta on there because it is still changing. Basically what we did was when we created the V2, it was basically we just kind of copied V1 and created V2. So it looks exactly the same, no advantage. But now we're cleaning it up. So basically some of the oddities and annoying things about our API we're fixing. And so the UI, CLI, Rancher Compose, most of our services in 1.2 are switching over to the V2 API. That will be released, and the V2 API is really much nicer than the V1. We will continue to support V1 for quite a while because honestly we have a lot of code that's using V1, so it is still supported. It still works.
Okay, great. Is it possible? This was Abhinav's question. He said, "Is it possible to watch for the event in metadata instead of using the conft interval-based polling?" So kind of like to listen and watch for events in metadata. Is that something that we're working on, or that's coming, on the metadata server side?
Okay, so the way this works is if you go to we have Go bindings to Rancher metadata. It's called Go Rancher metadata. And there's an API in there for on-change, and right now it is polling-based. But that's going to change to be dynamic. We're working on it right now. It's a key thing that has to be in 1.2 because basically all of our services are, before they would talk directly to the control plane, like to the central cattle process, but now they're just working off of metadata, and so we need more efficient metadata updates. But the caveat is all that we're going to tell you is something changed. And we do this somewhat on purpose because it's the way that we write our services, and we kind of encourage people to write the services is instead of like watching individual small pieces of data and trying to deal with multiple changes coming in, it's significantly easier to say, okay, something changed, reread metadata. It's a local service, so you can get all the data really fast. Reread metadata, and then reconfigure what you need to. So you're just giving an event that like something changed, read state of the world, read the desired state and then make your state match it. And so it's a kind of a programming practice like we kind of encourage because it makes services, idempotent, they're easier to scale, they're more resilient and everything. Yeah.
Okay.
There are a lot of questions.
Yeah, I know. Okay, a couple more. Lori asked, if I'm creating a stack not using the catalog, say a simple Ubuntu, and I want to mount an EFS volume to /data, can I do all that from the Rancher GUI?
Yes, you can. Yes. So basically, when you just go and you create a service, there's the volume mounts, and you just say you just give a date, you give the volume name, which is data, and what path you want it to mount to. And then if the volume already exists, we'll use it. If the volume doesn't already exist, then you have to put the driver option, or sorry, the driver name in the GUI. But basically, you can do everything from the GUI. It's just a couple more clicks and steps and whatnot.
Okay, cool. Thanks. Let's see, another one here. Surendra asked, hey, does this Rancher CLI completely support and compatible on the current stable 1.3 version of the Rancher/server? I'm guessing that means like 1.1.3.
No, unfortunately. When we announced the CLI, this actually came up. Somebody asked, will the CLI work against Rancher 1.1? And at the time, I said, sure, why not? Now, I have to take that back. Unfortunately, because we came out with the V2 API, and the V2 API is significantly better, and it has made writing the CLI easier, unfortunately, the CLI only works with 1.2. It does not work with 1.1.
So if you're using a 1.1 release, is the CLI exposed in the 1.1 release from the website? Or from the GUI, like to download it and stuff?
No. So in Rancher 1.1, all we have to download is Rancher Compose. And so in 1.2, there's two links. There's Rancher Compose and the Rancher CLI. The Rancher Compose is not anywhere. It's actually used quite heavily internally within Ranchers, so we need that service. So we'll have both of those available as a download. We will probably not as prominently feature Rancher Compose because the Rancher CLI largely does replace it. You can do Rancher up the same way you do Rancher Compose up.
Okay, a handful more questions. So one, if we're currently using data containers, this is Vincent. He was wondering will there be any sort of documentation on migration path to the cattle volume solutions?
So there's no reason you have to migrate. If you're happy with that approach or whatever, it still continues to work. All the volumes we're not going to drop any of that. There are some actual cool things you can do with them, some neat tricks and whatnot. So you don't have to migrate, but I think it would make sense when we release this to put out like a blog entry of hey, before this is how you're doing with data volume containers. Here's how you can do it with just volumes. And so I think it would make sense for us to put together some content around that.
Okay. Another question is it possible to run an in-service upgrade via the API without specifying a new launch config? Essentially, I just want to pull and recreate a container.
Yeah, so that does not change in the API, and we have had quite a few people kind of complain that that's too verbose or whatnot, but that hasn't really changed. But I will tell you from the CLI, you can just run the CLI. That will be a feature in the CLI of just say upgrade and you give it a new image name or just a new parameter, and then we interact with the API. Unfortunately, it's like there's a lot of weird corner cases of for the API unless we just create a specific one for just image, but there's I don't know, 20 fields on a container now. So there's a lot of weird caveats of being able to just specify one argument. But anyways, the CLI will handle it for you. And so that's what we've kind of done is or given people for the answer. The CLI works really well with the integrating the CI systems and whatnot, scripting and automating. So you can do that.
Okay. A question from Thomas, and this is, I think, a pretty good question. Not that the rest haven't been, but he was asking, would we be better off starting to use the 1.2 pre-releases now rather than waiting if we are planning on launching a new large environment in the next week or so? So sort of short term, I'm going to launch a large environment. Should I go with 1.1.4, the current stable, or should I just go with 1.2 pre-releases? What are the trade-offs here in terms of features, upgrade implications, and stability? I think it's kind of the top.
Right. So right now, the 1.2 pre-releases in many ways are actually more stable than 1.1, and it's more scalable, and you're going to see a lot of performance increases in 1.2. But the caveat is that we are still changing it. So I have to say, if you're looking at production, doing production workloads, I would stick with 1.1. If you're doing something where you're like, well, we're going to go to production in a couple months from now, then I would say just start with 1.2. But we are going to be changing. I mean, so the thing is Shannon has up here this slide of kind of latest Rancher enhancements, and you can see the last couple ones have been, these last two releases we've done have been kind of light on features, and the reason for that is the massive amount of work we've been doing behind the scenes to prepare for all of this new approach of infrastructure services and whatnot. And so all of that functionality is going to be landing in the next month. And so I would just say, like, we're generally pretty good at putting out stable pre-releases because they do have a QA cycle. But I can't in good faith recommend them for production until it's actually released.
Okay. There's another question from Alexi. He said, just came in, what is a good way to deploy Open LDAP server as a container that is managed by Rancher, but at the same time use this Open LDAP server to manage accounts? Seems counter-effective if one depends on the other, and same LDAP server is supposed to be highly available since a lot of external and internal services rely on it. Also, is there a way to deploy LDAP's service easily, as in if it exists as a Rancher catalog template, or some recommendations on how it should be done? Sorry, a lot of LDAP there.
Yeah,
kind of an
it's a little bit of it is a little bit of an inception if the LDAP server providing authentication for Rancher is managed by Rancher, but it is definitely feasible, and you can do that because authentication is like at the outer layer and it's not used internally. So let's say LDAP went down, Rancher can still, resurrect it and deploy it and do everything it needed to, because authentication is not in that code path. The problem you're going to have is you're not going to be able to look at like the website or use the API to access it. API gets a little fuzzy because I think there's a window of time you'll be able to access it. But so I would say if you're going to do that, then you should just know how to there is a way that if you really shoot yourself in the foot, you can go to the database and there's a settings table that you can flip authentication off, so you can get back in if things really go south. But it would work. You just kind of a little bit of a risk.
Good. All right, we're down to the last 4 or 5 questions, so try and bang through these. You were showing some shell scripts where the container was using Ubuntu 16.04 for the base. Is that what we're really going to use? It seems a bit heavy. No Alpine. What's up with that 16.04 Ubuntu thing and your script containers? That's from Poland.
Yeah, we get quite a bit. Okay, so here's the reality: is we've got enterprise customers and they care about security and patches and releases and whatnot. And so by attaching to an LTS release of a major distribution, it's much easier to address those things. So Alpine has presented some problems. I know they do. They're security focused, and they do address CVEs and stuff like that. but it's a little harder to convince enterprise people of that. So Ubuntu 16.04, that image is actually quite small in relative terms. I mean, like Alpine or BusyBox or whatever, those are like, let's say 5 megabytes, 2 megabytes, something like that. Ubuntu 16.04 is significantly smaller than the 14.04, and you're looking at like 40 or 50 megabytes. The thing is people make a big deal about the size of the image. The reality is, like, if I'm starting with an Ubuntu base, that's like 40 or 50 megabytes. When I start piling in all my Go microservices, it explodes real quick because Go is not small in itself also. We're talking about binaries that are like 10, 15 megabytes. Like Docker itself is like, shoot, I think it's like it's over 20 megabytes, might be 30 megabytes. So it's all kind of relative. Like we really like small and minimal, but at some point we have to be a little bit pragmatic about how we approach it. What we are doing, since the way we had before for Rancher was we just had 3 images: server, agent, and agent instance, and then everything was in there. Now that we've exploded everything out into microservices, all the images are becoming much smaller. And some of them are actually built on Alpine base, but the majority are still going to be Ubuntu 16.04. So anyway, that's kind of a long answer to that.
Yeah, he was. I think he was clarifying too. It's not just about the image size; it's also about the content, the security, etc. So, good.
Yeah, and so I mean, honestly, if you look at like what's in the Ubuntu base, it's pretty darn small. But yeah, I know this one honestly, it's a hard one for me because I really like Alpine, but it's like I kind of had to compromise a little bit and say like, oh, we're probably going to stick with Ubuntu base for a while.
Okay, Alexei had asked, is there a way to automatically configure ulimits on newly added hosts to environment, or at least some recommended settings to support high-load containers, i.e. hosts that would run container services for web servers, Redis, Mongo, Elasticsearch, etc.?
Right.
Tags or not.
So no. So the ulimits and whatnot, we don't really handle it because it's kind of like you come to Rancher with a host with Docker on it already, so we don't kind of manage the ulimits of the host. Basically, the approach that people do for containers is you set the ulimit to pretty much unlimited, like maximum. You put the open file descriptors to like 10 million or a million, something like that, on the host. And then you use the ulimit capabilities of the containers to then restrict it to the containers. So there's not much reason to, set any ulimits on the host because the containers can enforce it themselves.
Okay, we'll ask a couple questions. Srimant asked, how does Rancher handle request creation of, say, 1,000 short-lived containers on like 4 hosts? Does it queue the requests and go through them over time? Like, what's the scheduling like there, and how's it changing, or is it the same going forward?
Right. So Rancher's not really optimized for batch scheduling like that. Like, so, that sounds like kind of similar to like an HPC workload where you would basically like you get like 1,000 job requests, and you look at all the job requests, and then you figure out the best place to place them, and then push them out, and then you just kind of continue that loop. Rancher's not really designed that way. We schedule a single entity at a time, although that is in parallel, but we don't do batch scheduling, so we don't grab a lot of them. So basically, what you're looking at is just, well, what's the throughput of the system? They do effectively get queued based on the number of kind of concurrent processes run in the orchestration system, and the number of servers that you have. And so for 1.2, we're gonna come up with new performance numbers because it's quite different from 1.1. It's much better. So I can't really say like what's the performance going to be, how fast. The way Rancher has always actually historically worked is we actually can do a lot of things in parallel really well. Just not like, let's say like you can launch a container in 1 second. I could also launch 100 containers in 1 second. Like we've always been good at that, but the one individual one might take a little longer. So I don't know. I don't think that like directly answers it. Like we don't really design specifically for like that batch use case. If there's something you want to do there, I have been thinking about it, like how to make some of that
another
better,
place though where other schedulers are interesting. I mean, you could use Mesos for that kind of use case.
Yeah, yeah.
You could use Kubernetes. I mean, the different schedulers sort of have different strengths. So if your use case looks more like that, I would say maybe look at Mesos too as part of just deploy a Mesos environment for those kind of use cases. They tend to. I think that's one of the strengths of Mesos.
Yeah.
Okay. Alexei was just asking kind of to extend his ulimit question a second ago. What about ulimits and file descriptors on Mac OS? Seems like Mac itself limits very heavily.
That one I don't know specifically. I mean, we don't honestly do anything with Mac. We don't run on Mac or everything's Linux. So I'm not quite sure how to answer that question.
Okay. All right. I think the last one Alexei asked about an hour and a half ago, but I want to get to it. How is the local host machine added as a host to the Rancher server? What agent init string should be used? So you were demoing on sort of one machine. How do you do that? Is there something you can show?
How do you just add localhost?
Yeah.
I mean, so if you go to the like the Rancher UI and say add host, go to custom, then there's the command you can copy. But the catch for localhost is that there's a field right above where you copy where you can say what's the IP of this machine. Make sure you put in the correct IP for the machine, because otherwise we'll detect it as something weird like the Docker Bridge IP or something like that. And then that's it, and then you can just add the local one in.
All right. Well, I think we've covered everything. For those of you who are left, and I think amazingly we still have like maybe half of the people who were here a while ago still on the meetup. But if you haven't already, download Rancher, give it a play. It's really cool. I think we're now well over like 4,000 or 5,000 stars on GitHub. If you need any help, our forums are awesome. Just forums.rancher.com. You can go to docs.rancher.com to learn more. Rancher OS is now on version, I should update these pictures, is now on version 0.5 or 0.6, Darren? 0.6, I think. And it's become a long way as well. It's making a lot of progress. Seems to be growing very quickly. So give it a play. Try either of those. We also, I'll send out a recording. So if you didn't get this, you'll get an email with a copy of the recording. And, with information for next month's meetup. And like I said, feel free to respond if you have ideas, if you'd like to present something, if you want to share, something about a cool thing you're creating, or share your use case. We'd love to get other people presenting. So please let us know. Maybe we'll, maybe it'll get us done talking shorter than 2.5 hours next time. So thanks a lot. And thanks everyone for all of your time today. It was great talking to you. Thanks, Darren.
All right. Thanks.